this video is going to talk about how to solve an exponential equation where the base can be broken down or rewritten into a smaller base, which then will allow us to go and actually solve for x at that point in time. So if you take a look at this first example, 25 to the x equals 125 to the x plus 2. 25 and 125 are both numbers that can be broken down into a smaller base. By that I mean we're still going to have the same skeleton of a problem where I have something to the x and something to the x plus 2. And what I'm trying to do is rewrite 25 in a smaller version, smaller way. We're just rewriting it. We're not changing the value. It's still going to be equal to 25. But we're going to think of 25 in terms of 5 squared. And 125 can be written as 5 to the third. So I still have the exponent of x, I still have the x plus 2, but I've now broken down the two bases, so they now have a similar base. Following exponent rules that we know from earlier in our math careers, we know that when I have a power to another power, I multiply them. So this is actually going to become 5 to the 2x equals 5 to the, now be careful with this one because you're going to have to distribute. 3 times x plus 2 is going to be 3x plus 6. This was helpful because I now have two bases. Both of them are 5. I have an equation that is equal to each other with the same base. The only way that can be equal to each other is if the exponents are equal to each other. So I can make the conclusion then that 2x has to be equal to 3x plus 6. So at this point in time, I'm going to solve this as a algebra 1 equation. And let's subtract 3x from both sides. We're going to get negative x equals 6. So divide by negative 1, we're going to get x equal to negative 6. And I was able to solve this problem. Another second example I chose because it looks a little bit more challenging. The fraction might confuse you. But if you think about another way to write this, as I was saying, 9 is the same thing as 3 squared. And keeping the exponent as x plus 4, I'm thinking of another way to write 27, and 27 is 3 to the third. Now, looking at this problem as it stands right now, I don't have two bases. This left-hand side of the fraction is still, left-hand side of the equation is still a fraction. And normally we want to not have negative exponents in a problem because it's just not simplified that way, but we're actually going to create the negative exponent, bring this back up to the numerator using a negative exponent so that we now have the format like we had on the first problem where we have two bases that are the same. And when I have two bases that are the same and we're equal to each other, I can make the comparison that the exponents have to be equal to each other. I cannot do that if I didn't make that have a negative exponent. At this point in time, subtract 12 from both sides, so negative 14 equals 3x, so divide by 3. We're going to get the fraction negative 14 over 3.